Hello, JSConf. How are you? Yes, thank you. I'm Dominikus Baur, and as you might have noticed, I suffer from an all too common problem in the tech world, which is yet another bearded dude. And here's my totally scientific analysis of the JSConf speakers' profile pictures on the website. And as you can see, I'm not alone. There's so many of us. We should probably form a support group or something, or just shave those damn things off. I don't know. Anyway, so what does this bearded guy do? I'm based in Munich, Germany, and I work as a data visualization freelancer. And here are some of the projects that I did. So in the recent time, I had this Better Life Index and regional well-being pages for the OECD. I did Selfie City, which is an analysis of the selfie phenomenon with lots and lots of visualizations. And also Visits here, which is a visualization for personal travels. And you can find them all on my website, so check them out. They're, of course, web-based. All right, so let's start. I guess most of you know data visualizations, otherwise you wouldn't be here. So the basic idea is to turn complex data sets into visual representations, and if they're done right, then you can easily spot patterns and understand the underlying data. And this here, for example, is a pretty famous and old one, and it depicts Napoleon's march to Moscow. And in this graphic, you can see the course that the army took. You can see its shrinking size, so people are dying there. And you can also see the temperature down at the bottom, which might give you a clue why the army was shrinking. So you have lots and lots of information in an easily digestible format, and you could even argue that it's somewhat beautiful. So that makes datavis kind of the perfect tool for portable devices, I think. Just think of all the data that you're producing or have to work with while on the go. And visualization spares you from working with the raw numbers and gives you a quick overview to find out what's important. And with displays becoming even smaller now, maybe even watch-sized, it can quickly show you what's relevant or interesting to you without forcing you to look at a spreadsheet or so. OK, so how do we go about building these things? Of course, there's the native approach, but as you all know, that's a real pain to do it like that. So you have to support iOS, of course, but then you also have to support Android, and they're completely different. And then once you actually visit this zoo and try to do something for Windows Phone or BlackBerry or Bada or whatever they are all called, you're in a complete mess, and porting code isn't easily possible. So what better way to solve this problem than going to the web? So the mobile web has come so far in the last years that it's actually viable to develop full-blown applications even for mobile devices. And especially news organizations are very keen to create visualizations, interactive visualizations that work across devices, of course. So here's a couple of examples from the New York Times, who are doing an amazing job out there. But of course, there are other teams like The Guardian, Washington Post, and so on, that are also creating really cool stuff. OK, so what I'll try today is I'll try to give you a quick crash course of developing data visualizations for mobile devices in 20 minutes or less. First, I'll give you a quick overview. I'll talk a little bit about responsive web design and how that already gets us halfway to our target, I would say. But it's also interesting to pursue a mobile-first approach to focus on the strengths that you actually get from having a portable device that's also touch-controlled, which lets you do much more interesting stuff. And finally, of course, the big issue, I would say, in this whole topic is interaction. So how do you best support interaction on those tiny portable screens? If you need more inspirations for this topic, here's two websites that can give you that. So mobilev.is is one by Bo Ku, and another one is mobileinfovis.com by Sebastian Sadowski. And they're both just collections for mobile visualizations. You can have a look at those. They're ever growing, and there's really great stuff there. OK, what are the main differences between desktop and mobile? So first, the obvious one, interaction happens via touch instead of a mouse. So we no longer have this one single minuscule cursor, but we have potentially multiple fingers that are overlapping everything on your screen and just creating a mess. And we have very specific results of that. For example, we're losing hovering, or we're getting something else like hovering. I'll talk about that in a minute. But there's really a huge difference between that. And then, second, of course, we have different screen sizes and formats. So with a laptop or a desktop, we usually have relatively low res, large screens, 16 by 10 or 16 by 9 aspect ratio in landscape. And then on mobile devices, you have your high resolution, very, very small portrait-oriented screens. And this, of course, changes how you go about information layout, density, things like that. All right. If you want to develop datavis for the web, then I'll recommend one library that you might have heard about today already, so D3. That's kind of, we had this fantastic talk before where we saw that there's a huge, another zoo out there with all of those various types of charting libraries that let you do crazy things, all in different ways, but really D3 is kind of the lowest common denominator, so most people that are doing datavis know D3 or use it. So who here has heard of it? Who has used it? Cool. Yeah, so it really is pretty common. It's mostly being developed by one guy, Mike Bostock, who's working at the New York Times. I'm not sure if that gives them an unfair advantage, I guess, but yeah, who knows. So Mike is doing an amazing job. He's also producing lots and lots of examples for D3. So if you go to blocks.org, bl.ox.org, you can find hundreds and hundreds of those things with the really, really amazing stuff in there. So D3 has a very, very active community, and it's still being developed and it hasn't been abandoned 2 years ago or something like that. And what's really great about those examples here is that usually they work directly on mobile. So if you open up this page on your smartphone, for example, and try one of these, it usually just works, because the interaction issue isn't one for D3. So if you want to go from mouse to touch, usually you only have to change your event handlers a bit. So usually on a desktop, you would write something like that, on mouse down, do something. And for touch, those event names change to touch start, touch move, touch end instead of the mouse equivalents. And of course, those events can then appear multiple times because you have multiple fingers, and then you can keep track of those fingers and do pinching and stuff. And the nice thing is that most of D3 automatically does that. So you have certain behaviors that automatically support pinching, for example. So interaction isn't really an issue. What's an issue is screen size. So D3 leaves all the scaling to the developer, pretty much. And that means, of course, that your visualization then becomes really tiny on a small screen. So those are screenshots from blocks.org. As they would appear on your smartphone. Of course, imagine that thing a little bit smaller. And especially with like the tree map on the right here, you can't really read anything or do anything with it. So scaling is an issue. And of course, what do we do when we want to have our website scale? Right, we go to responsive web design, which is fantastic. So basically, you want to have a page that adjusts to the size of your viewport. And we can apply those same principles that we get in responsive web design to visualizations, of course. So you grab your favorite responsive web design framework, like Foundation or Bootstrap or whatever, and then your chart just becomes one of those boxes in your grid, and you give it a fixed width, and then it adjusts based on the device's screen size. So that's really useful. I'll show you an example from my own work where we use that. So the OECD Regional Wellbeing Project was something that I did with Moritz Stefana, and you might know the OECD. It's a big organization that collects data on well-being and how people feel worldwide. And this project here, regional well-being, focuses on certain regions on the globe. So you can check out how well people are doing in certain aspects. So we have things like safety, the job market, education, and so on. And they asked us to create a visualization that lets people easily explore this data. And our idea was to focus on a certain region and then let people explore from there. And what better region for that than the one where people actually live at the moment. So this page starts with your home region, and then you get this nice visualization that shows the various aspects of well-being. You get a list of similar regions to your own, which sometimes is very surprising. And then down at the bottom of the page, you get an overview of those quality factors in detail, so you can compare, for example, safety to other regions in your country, and so on. OK, so you can just browse that. You can then jump from region to region. But as we didn't have the budget to actually create 3 different websites for 3 different form factors, we made the whole thing responsive. And if you're trying it on your tablet or your smartphone even, you might see that it should just work. And here's kind of the underlying magic. So all of those pink boxes are our grid elements in Bootstrap. And yeah, by just putting those visualizations into those boxes, you actually get the whole responsiveness for free. And depending on your screen size, of course, the layout changes. Some elements become bigger on smartphones, for example. And as you can see, like those 3 detail views in a row become 2 and then 1 on a smartphone. So it actually works pretty well. But of course, that's not everything. There are kind of those little details that you learn on the go, on the job. And I'll talk about those a bit. So one thing is, drawing a visualization is usually quite heavy on the CPU and the battery and so on. And you don't want to kill your browser tab just because you decide that you want to redraw your visualization every time the user adjusts the window size by 1 pixel. So that's when something like debounce, for example, or throttle comes in really handy. I usually use the underscore version, but there are, of course, other implementations out there. And the basic idea behind all of those debounces is that you give it a function, in our case, render, and this function is at most called every, here, resize refresh rate milliseconds. And if you set that to, I don't know, 300 milliseconds maybe, then it's only drawn every third of a second, and not like hundreds of times per second, which is quite useful. And you might also see that if you actually try it on your laptop and adjust the size of the window, then you see that the visualization takes a bit to be redrawn, but at least that keeps us from crashing the browser window, which is nice. All right, another thing are meta viewports. So that's something that you want to set on mobile devices. It's just in the header of your HTML, and there's this meta tag called viewport, and you can define certain things how mobile Safari or mobile Chrome displays your website. You can say, for example, that width equals device width, which means that the website is initially as big as your screen from the width. And you also want to set the initial scale to 1, so it's actually zoomed to 100%. And sometimes it might even be useful to say something like user scalable equals no, which means that people can't enlarge your page by pinching. Depends on the application, if you actually want to do that. And finally, one last thing when it comes to responsive visualizations are SVG viewports. So most of those visualizations are built in SVG. I guess that's the most common application. Also, all the D3 examples use SVG, usually. And what's nice about SVG is that, as the name Scalable Vector Graphics implies, it's actually a vector graphic, so it can easily be scaled. And you can even control that using CSS. So with the viewbox attribute here, you can define your own virtual coordinate system within the SVG. So here, this coordinate system goes from 0, 0 to 500 by 250. And everything that you draw within the SVG is then scaled according to this coordinate system. And what you also want to do is you want to define that the aspect ratio of your virtual coordinate system always stays the same, and that's what the second attribute does, preserve aspect ratio. There's actually two parameters. The second one, meet, means that your SVG is always scaled so that everything is visible and nothing is cut off. And the first one, the x mid, y min thing, says that your viewport, your SVG viewport, should be centered on the horizontal axis, x mid, and should be aligned with the minimum on the y-axis. So it looks like this. So if the SVG actually fits into your window, everything's fine. And here it's a bit different. Here is where you actually get a horizontally centered box, which is your SVG. And it's also kind of a rare site in web development, so you get that for free if you set those attributes. OK, but let's dive a little bit more into details when it comes to mobile data visualization. So what happens when you actually approach this whole problem from a mobile-first design perspective and see what comes up? So first of all, usually the person that uses your visualization on their smartphone is like this woman here. So they're in the middle of something. They're not in the mood for any of your fancy UI shenanigans. They want the data as quickly as possible. So I would say always, when it comes to mobile interaction design, just going to let that loop. When it comes to mobile interaction design, think about what's the task of the person that's using your app or your visualization or whatever, and then try to support that as well as possible. And what's really helpful with designing something like that is, sorry, I have to take your picture away now, guys. What's really helpful is that you can get certain aspects of the context using the new HTML5 APIs. So one of those is geolocation. Who has used that already? Yes, awesome. So this one's really great. It basically gives you the user's current position, global position, in this little amount of code. So you just call get current position, you give it a callback, and hopefully you get some latitude and longitude. So we use that as well in the regional well-being project. So if you open it up on your smartphone or your browser, then you get something like this pop-up here that asks you if the website is allowed to use the current location. So you can also see that it's actually much more privacy conscious than the server-based solutions that just do it based on your IP address without ever asking you. And once you set that up, you get the visualization starts on your home region or the region that you're currently at. So it should show Berlin right now if you try it. And that's really nice. So you don't have to pick that from a list or anything. You just get it for free. Another aspect when developing for mobile is, of course, performance and battery drain. So you want to have fast, beautiful graphics, of course. But you also want to be careful that you're not actually draining the battery in the process. So there are a couple of graphics technologies that you might want to use. So SVG, of course, I already mentioned that. It's vector-based, so it scales nicely. It has DOM integration. You can tie events to certain elements of it, but it's somewhat slower than the other alternatives, I would say. Faster is Canvas, which just gives you a plain canvas, and you can draw on that. But kind of a downside is that it's very low level, so you actually have to draw on your canvas. You don't just say, OK, here's a rectangle, and it's going to stay there. You have to draw it every time. And you also don't get a DOM, so you have to figure out yourself where the user now tapped. And it's kind of the same with WebGL, which is probably even faster than Canvas, and it's able to do 3D, which is awesome. But again, it's very low level. It has no DOM. So basically, pick your poison. And by now, WebGL is even supported in iOS 8, in the upcoming iOS 8, so it's viable to use that. All right. When we talk about interaction on mobile devices, the main problem is probably the fat finger problem, which means that you're using those thingies here to interact with anything on your smartphone. Most smartphone companies recommend a certain minimum size for on-screen elements. So Apple says 44 by 44 pixels, but yeah, it varies, but it's always something in that range. And of course, you have to make sure that all your interactive elements are big enough that people can actually interact with them. Sometimes you can avoid the fat finger problem altogether. So in the Selfie City project, for example, that I did with Lev Manovic, Moritz Stefana, Daniel Godemeyer, and a couple of other amazing people, we looked at the differences in selfie-taking practices across cities worldwide. Yes, you can do that. And part of the project was the self-exploratory that you can see here, where you can explore the data set. So you have filters at the top, where you can filter the selfie collection based on head orientation or glasses, smiles, and city and age and stuff like that. And then you get the results at the bottom. And what was good for us was that everything was big enough that you could just use it on your fingers, so it kind of with your fingers, so it worked kind of out of the box. But of course, the problem is, what do you do when you want to show really high resolution visualizations that are still interactive? And again, there are a couple of tricks that you can use. Probably the most common trick is invisible touch areas. So the idea here is that we have the scatter plot, and we want to have people being able to tap on the circles, and of course, they're much too small. So we create those not very invisible here circles, the orange ones. So mostly you just set the opacity to 0, give them a high Z index, so they're actually on top of everything, and maybe position absolute and stuff like that. And then you add your touch event listener, and then, of course, those circles have to know which parts of the data they represent. And based on that, you can then have those things be interactive without actually displaying them. But of course, as you can see, it doesn't always work. Even here in this very simple example, we already have this overlap between two circles. So what happens more often is that you just create a full rectangle, another invisible rectangle, opacity 0, put it on top of your graph, and then every time you have a touch event, you try to figure out, okay, which part of the data is the finger closest to or something. And then I show the tooltip or filter or whatever. And talking about tooltips, that's probably one of the main problems when it comes to touch-based visualizations, because as I said, we no longer have hovering really with fingers, but tooltips are really ubiquitous in visualizations. They're pretty much in everything because it's such a nice solution to display details on demand just by showing a little tooltip. And in mobile Safari, for example, we kind of have hovering, but it's weird, and you've probably already seen that. So if you tap on an element that has some mouse over event defined once, it triggers the mouse over event, and then when you tap again, it's a mouse down. And for most people, that is just totally confusing, because they tapped on something, and then this tooltip pops up, and they are not really sure, are they able to tap again or not? So I can't really recommend that. A better solution is just have your always-on tooltips. They're always visible, but they're tied to some type of interaction. So in this example from the New York Times, for example, we have two solutions that apply this. So first, we have this little tooltip there that's tied to the slider, and you can just move that around. And you also have here this banner-like thing at the bottom that's always visible and shows you information. So I would say that's probably a good solution to have something like that. But then, of course, you don't only have downsides. You can also do amazing things with multi-touch and gestural interactions. So one idea is to keep track of all the touch starts on an element and then decide what to do with it. For example, rotation, scaling, or so. Frameworks can also help you. Here's two examples from D3. And those handle multi-touch automatically. So if you open them on your tablet, for example, then you can pinch to zoom this world map, and you can move multiple circles around using multiple fingers. If you want to be more fancy about that, you probably want to use some gesture library like Quo.js or Hammer.js. And those even detect full gestures, so you get stuff like swiping and pinching, rotating, long press, and so on. So you can go totally crazy with that. And if you're building something with touch first in mind, then you can kind of look at your visualization as something that's deformable, some physical object that you can play around with. That's what I tried to do in this research project here, which isn't playing. Here we go. So that's TouchWave. And in TouchWave, we had a stream graph. And the idea behind the stream graph was that you could just manipulate it using your fingers. So as you can see, you can just stretch it and enlarge it. You can double tap on it to change the layout. So we went as far with the metaphor as we thought useful. Yeah, and if you really want to do that, so that project is already 2 years old, so I had to implement it natively. But by now, it should probably even work on the web. OK, here we go. All right, something that you can do right now is you can use, for example, the device orientation events, which is really cool. So those actually give you the orientation of the device in space. We've already heard about talk about that yesterday, which is really neat. So you can use that, for example, to build one of those little demos here. You can check that out on your smartphone. You have this little globe, and when you orient your device in a certain way, then it spins around, which is a neat effect. And you can probably do all kinds of crazy things when it comes to visualization. I don't know, 3D maybe, even though that's somewhat of a four-letter word in the community. But yeah, you could use that, build it right in your browser. OK, that's it from me here. The links to some of the examples, you can find all the stuff on my website as well. Talk to me on Twitter, send me an email, or talk to me later in person. Thank you.